Hey guys, welcome back to Eureka, and in this video I'm going to be doing revision for the mechanics periodic on week 11. We're going to start with basic questions, and let's start with basic question number 1. It gave you all of these equations. Read the question yourself, and in part A it tells you what are the x and y components of the velocity. The velocity is given by this equation, plus 15 minus 10t j. That's given in the question, so the x component is 20, the y component is this thing. Part B. Justify that when time equals 0, the velocity equals 25. If time is equal to 0, then the velocity is equal to 20i plus 15j. Okay? In other words, our velocity's magnitude is going to be equal to 20 squared plus 15 squared, all under a square root, which, in other words, it's the magnitude, and 25 meters per second. Part C. Determine the displacement in the interval 0.1 seconds to 1.0 seconds. What is displacement? It's delta r. Delta r is r final minus r initial, right? So we need to find our position at 1, subtract from position at 0.5. Position is given by 20ti plus 15t minus 5t squared j, right? Look at the question, it's given. When time equals 1, you get 20i plus 10j, I believe. This is when time equals 1. When time equals to 0.5, you get 10i plus 6.25j. Let's subtract them. We said t1 minus t 0.5. We get 10i plus 3.75j. And if you want to find the magnitude of the displacement, you literally say 10 squared plus 3.75 squared, right? So using a calculator, you should get 11 meters. That's part C done. Part D. Determine the position at which the baseball hits the ground. So if you throw a baseball and it hits the ground, you have 2 points when you're on the x-axis, when you actually hit the ground. So if you hit the x-axis, your y component of this displacement is equal to 0. In other words, if r is equal to 20it plus 15t minus 5t squared j, your y component of the displacement should be equal to 0. When does that happen? It happens when the time is equal to 3 or 0. We don't want the origin, we want this point. So at time 3. When time equals 3, your position vector, your displacement is equal to 60i. And they're telling you find the speed at that time. Well, velocity is equal to 20i plus 15 minus 10t j, right? Okay, so we get 20i minus 15j. Now speed is the magnitude of velocity, so let's find its magnitude. And surprisingly, we get 25 meters per second. 25 meters per second is actually our initial velocity, or initial speed. Keep that in mind. Finish question 1, let's move on to question 2. At time 0, the position vector is given by that, and the velocity is given by that, and at time 2, 6 seconds, blah blah blah, given by that. Part A. Find the displacement between when time is equal to 0 and when time is equal to 6 seconds. Okay, displacement is just r final minus r initial. So we need to find rt2 and subtract with rt1, right? Great. R at t2 is given by, if you read the question, it's 6i minus 5j. And r at t1 is given by minus 4i plus 3j. Let's subtract these to find delta r. So minus 6i minus 5j minus becomes a plus. And yeah, in the end you get 10i minus 8j. That's part A done. Part B. They're telling you find the average velocity on that interval. Average velocity by definition is delta r over delta t. We found delta r to be this, so it's going to be 10i minus 8j, and your time is 2 seconds. Part C. They want the average acceleration. Average acceleration is delta v over delta t. On the same interval, by the way, they said from 0 to 2. This is why I'm using the same delta v and the same delta r. So delta v, we found it to be this, and t is 2. Sorry guys. I meant 6 over 6. And you're going to get 10I minus 8j over 36. Moving along, basic question number 3. Define uniform circular motion. I'm not going to define it, you define it. Part B, what is the relationship between instantaneous speed and the radius? Instantaneous speed denoted by v. V vector means velocity. V without a vector means instantaneous speed. 2 pi r over t. T being the period. T means the amount of time taken to complete one full rotation. That is the definition of period. Let's move on to basic question number 4. A body M moves on a circle of radius 6 with a constant rate, basically UCM, uniform circular motion, at one turn every 12 seconds. One turn every 12 seconds means the period. The period is 12 seconds. Great. And when time equals 0, the object is on the positive y-axis. So the object starts from here and it moves clockwise if you read the question. Part A, they're telling you, and of course the radius is 6. Part A, they're telling you, find the average speed between 0.2 and 3.0. Sorry, between 0.0 seconds and 3.0 seconds. Okay. If I'm speaking too fast, then I'm quite sorry about that. Speed is equal to distance over time. How do you find distance? Well, distance between 0 and 3 seconds is like this. By the way, how did you know that this is 3 seconds? Well, look, our period is 12, right? We want to divide the circle into 4 parts, and we know that the object moves uniformly. So we can simply divide by 4, we'll get 3. So here it's 0, here it's 3, here it's 6, here it's 9, and here it's 12. So 0 and 12 coincide with each other. How do we find the distance? Well, it's this arc length. How do we find the arc length given by this? Well, if you have a look, it's actually 1 over 4 of the whole circle. So 1 over 4 of the circumference of the circle is just pi over r over 2. Pi r over 2, sorry. Our radius is equal to 6, and 6 over 2 pi is just 3 pi, right? Okay. And we know that the time is 3 seconds, so our speed is 3 pi over 3. In other words, our speed is pi meters per second. Part B, find the average velocity on the interval 0 to 3 seconds. So what is average velocity? It is final position minus initial position. In other words, it's this vector over the time, of course. So how do we find this vector? It's going to be your final position, which is 6i, minus your initial position, which is 6j, over the time, which is 3. You're going to get 2i minus 2j. That's your answer. Then let's see if they're telling you find the average acceleration. Average acceleration is, of course, on the interval from 0 to 3. Average acceleration is delta v over delta t. Delta v is just velocity final minus velocity initial. Velocity final, which is here, we know that the magnitude of the velocity is 2 pi r over t, and it's constant. In this case, it's pi. So here it points downwards, so it's minus pi j, and here it points to the side. It's gonna be pi I, right? But then since it's final minus initial, we're gonna subtract from the initial, and our time is 3 seconds. So this is your answer. Let's move along to question 5. A body M moves in a anti-clockwise direction on a circle of radius 8 with a constant rate of exactly 2 turns 2 turns per 8 seconds. One turn is in 4 seconds, right? So our period is 4 seconds. Great, that's off my chest. And then they're telling you, the body, when time equals 0, it starts on the positive x-axis. It starts on this point and it moves, let's see. Does it move clockwise or counterclockwise? They didn't specify that. Oh no, they did. anti-clockwise, so counterclockwise. It moves like this. They're telling you find the period, we just did. We found the period, and then they're telling you find the instantaneous speed. Instantaneous speed is always equal to 2 pi r over t. 2 pi r over t. So it's going to be 16 pi over 4. In other words, it's equal to 4 pi. Your instantaneous speed is always 4 pi. Part C. Find the instantaneous velocity when time equals 2. If the period equals 4, we will divide the circle into 4 equal parts. 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. So at 2 seconds, you're here. They're telling you find the instantaneous speed at 2 seconds. This is the instantaneous speed at 2 seconds. And we found that the magnitude of the speed is 4 pi. We just need to add the direction. Our direction is downwards. How do we represent downwards? It's minus j, right? Minus j multiplied by 4 pi is just minus 4 pi j. Part C is done. Let's move to part D. They're telling you, oh my god, come on. They're telling you find the average velocity between 0 and 2. So find your average velocity between this and this. Average velocity is different from instantaneous velocity. Average velocity is defined as delta r over delta t. Delta r is just r final minus r initial. Our r final is equal to, our radius, by the way, is equal to 8. It's given in the question. So this vector is going to be minus 8i, and this vector is going to be plus 8i. But then we need to do r final minus r initial, so we do final minus initial. And of course, our time interval is 2 seconds, so we're going to be left with minus 4i. Sorry, we're going to be left with minus 8i. Part E. Find the average acceleration in the interval from 0 to 2. Average acceleration is defined as delta v over delta t. Delta v is just final velocity minus initial velocity. Our final velocity is minus 4 pi j. Our initial velocity is 4 pi j. But we need to subtract them, so we do this. And of course, our time interval is 2 seconds, so we're going to be left with minus 4 pi j. That's it. Let's move. Some people, without mentioning names, always say we have to be fast and furious. Haha. The cringe level is above 9,000. Question 6. A body has that mass and it moves on a circle of radius 0.5 meters. And it tells you that it does 0.25 turns every 1 second. This, by definition, is the frequency, the amount of turns per second. But the period is 1 turn per second. So how do we find the period? The relationship between the period and the frequency is that frequency is 1 over the period. In other words, the period is 1 over the frequency. The frequency is 0.25 turns, so t is equal to 1 over 0.25. In other words, is equal to 4 seconds. Great. Our period is 4. We've done part A. Let's go to part B. Find the direction and the magnitude of the force acting on the object. Well, force is equal to ma. A is the magnitude of the force in this case, so 0.2 kilograms multiplied by v squared over r, that's the acceleration. Now v squared over r is just 4 pi squared r over t, right? Okay. So 0.2 multiplied by 4 multiplied by pi squared. Our period, we found it to be 4, so t squared, of course, 16. And our r is equal to 0.5. Simplifying this would give you, let's see, what would this simplify to? 1 over 40 pi. Pi over 40, and of course, pi squared. Great. Pi over squared Newton, pi squared over 4 newtons. But what direction? Well, our acceleration in uniform rectilinear, in uniformly circulated motion is always towards the center. In other words, it's centripetal. Great. Done with that. Basic question number 7. Two bodies, B1, B2, are moving in a circle. They're telling you Find the ratio of their acceleration if the radius of one is equal to twice the radius of the other. Well, let's do it. If r1 equals to twice r2, the acceleration at r1 is equal to 4 pi squared r1 over t squared, right? And in the question they told you the speed and the periods are equal. So yeah, and here it's going to be 4 pi squared r2 over t squared, right? But we know that r1 is equal to 2r2, so let's just substitute 2r2. Now they're telling you find the ratio between this and this. If you put 4 pi squared 2r2 over t squared over 4 pi squared r2 over t squared, this would cancel out with this. You're going to be left with 2. So the acceleration of one is twice the acceleration of the other. In fact, in general, if you have the radius of one is equal to some constant x multiplied by the radius of the other, then the acceleration of one is equal to x times the acceleration of the other. Keep that in mind always. Basic question number 8. A yacht is traveling with that velocity and the boat is traveling with that velocity. Part A, the velocity of the boat with respect to launch. We know that the velocity of A with respect to B is VA minus VB, right? Okay. In this case, we want the velocity of the boat with respect to launch. So velocity of boat minus velocity of launch. Launch in this case just means the yacht. Yacht, I said. Velocity of the boat is equal to 8I minus 3J. And the velocity of the yacht is equal to 21I plus 16J. Let's simplify that. You get minus 13I minus 19J. And then in part B, they're telling you find the speed. Well, the speed is just the magnitude of the velocity. So it's the square root of 13 squared plus 19 squared in this case. Minus 13 squared minus 19 squared, but the minuses cancel out anyways. So this is your answer. You'll get about, I don't know, like 23 meters per second. Basic question number 9. Velocity of two particles A and B are given by these two equations, and the velocity of A with respect to B is given by 2I minus 3J. Okay, great. We know that VAB is just equal to VA minus VB. I previously said that. Okay, VA is equal to AI minus 7J given, and VB is equal to 5I plus BJ. Okay, so all we need to do is subtract them. So AI minus 5I minus 7J minus BJ is equal to 2I minus 3J, right? Let's simplify that. We get A minus 5I plus minus 7 minus B. J is equal to 2I minus 3J. Let's simplify that further. That means A minus 5 is equal to 2 and minus 7 minus B is equal to minus 3. Since they're equal, then their components are equal. So this is equal to this and this is equal to this. In other words, A equals 7, B equals to minus 4. Next, question number 10. A pilot wishes to fly his aircraft at 160 due east. So the velocity of the plane with respect to ground is supposed to be 160 east. East means I. Okay. On a day when the southerly wind is blowing at 120, at 120 kilometers per hour. Southerly wind means it comes from the south, it goes to the north. In other words, the velocity of the air with respect to the ground is equal to 120 J. They're telling you what direction should he steer his plane and what is the airspeed. At what airspeed will he be traveling? That means they want the velocity of the plane with respect to air. We know that VPJ is equal to VPA plus VAG, right? We need to find VPA. In other words, VPA is equal to VPG minus VAG. Take this to the other side. All we need to do is just literally substitute. And that's our answer. They want the magnitude and the direction of that. Well, how do we find the magnitude? That's pretty simple. You do this. And if you want the direction, you do this. That's your answer. Use a calculator. Basic question 11. A light aircraft is flying in still air. So basically, the velocity of the plane with respect to air. is 120 kilometers per hour on a bearing of 52. If it's a bearing of 52, that means this angle is 38, right? So in other words, it's equal to 180 multiplied by cosine 38i plus sine 38j. That's the vector equation of your velocity. Remember the polar coordinate formula? Okay. And then it tells you a steady wind suddenly springs up, blowing north at 70 kilometers per hour. That means your wind with respect to the ground, air in other words, with respect to the ground, is just 70 J. It's telling you find the velocity of the aircraft with respect to the ground. Find this. So we have VPA and we have VAG. All we need to do is just add them, right? Because VPG is equal to VPA plus VAG. Let's just substitute. So 180 cosine 38i plus 180 sine 38j plus 70j should be our answer. Now using a calculator, you'll get 141i plus 181j. That's it. Let's move, let's move, let's move. Let's be fast and furious. I can't believe I'm saying these words. Da-da. Basic question number 12. Yeah, you read it yourself. I'm just going to solve. Part A, it tells you find the velocity of B relative to A. So find VBA. VBA is just VB minus VA. In the question, the velocity of B is given to be 8I minus 6J, and the velocity of A is given to be 5I minus 5J. Simplifying that, you get 3I minus J, and that's the velocity of B with respect to A. Part A done. Let's move to part B. Part B tells you find the position vector of B with respect to A at all times. So find RBA. RBA is just equal to RB minus RA, right? Now we know that RB is equal to VBT plus RB initial, right? We know that RA is equal to VAT plus RA initial. So all we have to do is find these equations and subtract them from each other. So let's do this. The initial velocity of B with respect to origin is 8I minus 6J multiplied by the time plus, and we need the RBI. RBI is given by 2I minus J, right? So this is for this, and let's find this. The velocity of A is 5I minus 5J. Oh my god, 5I minus 5JT plus, and we need to find that it's given, it's all given, and now we just need to subtract the formulae, right? So we're gonna have, oh my god, what's wrong with my pen? So we're gonna have to expand this, and simplify. So 8 IT minus 6 JT plus 2I minus J minus 5I plus 5J minus 3I, I believe. Great. This is going to be fun. Let's group the I terms. So we grouped this, this, and this. Oh, of course, I forgot the 3i. And this, and let's group the j terms. Great. Now, let's simplify. This is going to be 8t, 5, so minus 8i, plus, and let's simplify this, you get minus 6t plus 4j. Oh, I did something horribly wrong. 1 second. Where did I go wrong? Let's see. Let us see. Okay, I did something wrong with the subtraction. Okay, wait. I did something wrong with the subtraction. Of course I did. I don't know math. Okay, guys, this is correct until now. You just have to subtract this equation from this equation. What I did here is some weird ass math. Forget about this. But this is correct until now. The explanation is correct. Just subtract this equation from this equation and you'll get the answer. And part C, they're telling you, at what time are the ships closest together? At what time are the ships closest together? That means we need this to be true, right? We need this to be true. Looking at their answer, because I did some wrong math over here, I'm just going to look at the answer sheet really quickly. It's 3t minus 1i plus minus 1 minus tj, and that's the position of r with respect to a, right? Okay, and we need the velocity of AB, which we found in part A to be 3i minus j. 3i minus j. We need these to be perpendicular. Sorry, we need them to be perpendicular. What does that mean? If they are perpendicular, then the dot product between them should be equal to 0. In other words, 3t minus 1 multiplied by 3 plus minus 1 minus t multiplied by minus 1 should be equal to 0. Right? Because that is the condition of, perfect timing, if you want to call it. And the dot product of two vectors, if you have, I can't believe I'm going to explain this to you guys. If you have a vector r and it's given by xi plus yj and another vector v li plus vj, then r dot, oh my god, r dot v is just equal to xl plus yv. And when two vectors are perpendicular, then their dot product should be equal to 0. So in other words, let's find the time when it is equal to 0. So 19 minus 3 plus 1 plus t should be equal to 0. So 10t minus 2 is equal to 0. Time is equal to 1 over 5 hours. 1 over 5 hours. Let's change that to minutes. You get 1 second. You get 12 minutes. 12 minutes. So your perfect timing is 12 minutes. So your initial time is 12 o'clock. 12 minutes later, you'll be at 12:12, and that's your perfect timing. Let's see. We have question 13 left. Question 14 and question 12 are the same thing. I'm just going to look over question 13. Let's see. Okay, and question 13 is like question 12, so you guys should be able to do it. And of course, as always, thank you guys for watching. This is part 1, by the way. Part 2 is coming out for chapter 4. Thank you guys for watching, and as always, easy, easy.